Why do one size fits all climate solutions often fail? And could the solutions we chase to combat climate change end up creating new problems for the people and environments we hope to save? Welcome to the Boring Climate Podcast, a platform where we encourage serious climate conversation. In this episode, we sit down with Dr. Chirag Dhara, a quantum physicist turned climate scientist, whose work challenges us to look beyond easy solutions and embrace the complexity of our warming world. He currently serves as Assistant Professor of Environmental Studies at Krea University. He holds two doctorates, one in Earth System Science from the Max Planck Institute and another in Photonics from the Institute of Photonic Sciences in Spain. Dr. Dhara's academic work bridges the rigor of theoretical physics with the complexities of climate science, allowing him to approach Earth systems with a multidisciplinary lens. He also led India's first comprehensive climate assessment report. Join us as we explore some of these themes and try to better understand the unique vulnerabilities faced by India in building a more climate resilient and equitable future. Welcome to the show, Shira.
Thanks so much, Vishwada. My pleasure to be here.
So, we'll start off with your background. You are a quantum physicist and climate scientist, and this is a rare kind of combination. What inspired you to make the transition to climate science, and how does your physics training help with your current research?
Yeah, a question I keep getting asked pretty often. I started out in physics because that was my interest for a very long time since I was in school. And but aside from physics, I was very passionate about physics. I still am. But aside from physics, I always took an interest in social issues and environmental issues and so on, just instinctively. Um, And eventually, even while I was doing my PhD in physics, I started to ask myself, is this what I want to, this kind of abstract work, mathematical work that I was doing, is that what I wanted to dedicate myself to in the future? Or do I see something which is more encompassing of larger sort of societal issues? That's where I started to think I, in order to continue remaining passionate about my work, I needed something more than just the physics and the mathematics, and that's where I thought a lot. It was a very deliberative process, and eventually I decided to get into climate science as something which is connected. The science itself, of course, is informed by my own physics background, but it has larger connections to politics, to society, to vulnerability and impacts and so on. So that's when I decided to switch. Yeah.
Nice. To kind of set context for our listeners, before we get into what you do, we'll kind of understand how exactly the planet is warming and its effects on India. And one of the things that your kind of studies point out to is the interconnectedness of these different systems, planetary systems and Earth systems that contribute to this. Could you tell us a little bit more?
Well, a part of my work does remain specifically in the climate sciences. So that's where we use data, observational data, which is very often from IMD, Indian Met Department, and climate models. So I work with colleagues at the Indian Institute of Tropical Meteorology in Pune. I used to work there in the past, and they have an Earth system model which they've constructed themselves, and that's been very valuable to our work. So aside from that, there's also a great deal of modeling data that's available from the CMEP6, state-of-the-art CMEP6 archive. So we analyze that data to get insight into climate projections, climate trends, climate projections, attribution, and so on. Now, in terms of the systems perspective, that's the part of my work in the last 3 or 4 years, where climate change is now often framed as the problem facing us, humanity. But in fact, uh, I think instead of saying anthropogenic climate change, it's much more important to see it as anthropogenic global environmental change, which also involves changes in the ecological systems, which form the foundations. That's where our development comes from, our food, our water, our natural resources, everything comes from the environment and eventually goes back to it. So unless we see how we are impacting the ecological systems along with the climate system, we won't truly have solutions that span the entire scale. They may be too myopic in the view. So in short, systems view. I can elaborate on that later if necessary.
Sure. So, in fact, that kind of leads me to the next question. With this systems view, how much more vulnerable is India and, say, other Southeast Asian countries? As many studies point out, we are more at risk, both in terms of dealing with the climate challenges as well as the climate challenges facing us. So, what does the systems view tell us
Yeah.
about these regions?
Let's take an example. Not, it's more of a thought experiment, but with real ramifications. One of the problems of climate change is decline in food production. Because food crops, they have specific climatic conditions under which they grow optimally. Now, if those change substantially enough, uh, plant growth and plant productivity, crop productivity is not optimal. So decline in food production is one of the major issues. But decline in food production is not just because of climatic shifts. It also happens for many other anthropogenic reasons. For example, the more pesticides we use, the more biodiversity in the soil we are killing off, the more pollinators we are driving towards extinction, and that is something which is happening worldwide. Soil biodiversity has dramatically dropped, which means less nutrients for plants. Uh, Pollinators have declined worldwide. Insect populations have crashed all over, but pollinators are critical for plant growth and to maintain diversity because they cross-pollinate across vast areas and so on. Now, in the absence of pollinators and the absence of soil biodiversity, also food productivity declines. So if we look at food productivity decline only in terms of climate change, we will come up with solutions such as GMO, but that itself may not solve the problem of pollinator loss or soil biodiversity loss because that happens for other reasons of anthropogenic change, which is why the systems view is so critically important. And that is also something that's happening all over the subcontinent, this South Asian subcontinent, and really worldwide. So that is the added vulnerability which we will miss if we only take a climate change centric view of the problem. We frame it as a climate problem.
So you earlier touched upon the models you use, both Indian and global models, but these are mainly top-down approaches to assessing climate risks. In a lot of your work, you also advocate for bottom-up approaches. What does this look like, and what does this mean?
Bottom-up approaches are led directly by the community. So let's take an example, and this one is from Chad in Africa, where one of the conflicts in recent times has been between farmers and nomadic herders, both of whom are looking for water resources to use, increasingly scarce water resources. So one can do this through remote sensing. You map out land use change, or you map out or try to map out migrating patterns. But of course, there are real limitations to doing a satellite measurement. What's happened there is some communities have taken it upon themselves to create an actual on-the-ground map. So they have mapped out where herders are migrating seasonally, where farmers and their croplands are placed, and where the fishing community is placed, and who requires resources at what times of the year, and therefore what can compromise solutions be in order to reduce the conflict between all of them. Now, even more important in terms of climate change risks, because with changing patterns of rainfall, some of these some of these pressures are getting exacerbated, and therefore all the more important to have coordination between different interests for the same shared common resources.
Right, which was also your kind of attempt with leading India's first climate assessment report, which filled an essential gap in understanding or having a document that captures our local realities. What did this report, what were the findings of this report? Some of the significant things that we should know.
Yeah. Uh, Rather than speak from that report, which is from 5 years ago, I'll speak from actually a paper that we've written, which we expect to be out. It's under peer review in PLOS Climate. We expect it to be out in the next few months. So I'll actually talk about the results from there because they are robust. Uh, One of the things we assess for temperature, for warming in India, is that Since the 1900s, the country has warmed about zero point 0.9 degrees, which is slightly lower than the estimate for the global uh, warming signal, globally average signal, which is about 1.2 to 1.3 degrees at this point. Reasons being tropical regions generally warm slower than exotropics because of different feedback effects there and so on. And also the aerosol loading over India, one of the suspicions and land use change. So we believe that these have also contributed to muting warming over the subcontinent. Regardless, about zero point 0.9 degrees is what we assess. And in the future, by mid-century, we assess a further increase of about 1 degree between now and mid-century, so quite significant. Um, when it comes to extremes, temperature extremes, the warmest times of the year have increased even more than the average warming. So about 1.5 to 2 degrees warmer. Extremes are what we are finding now in certain parts of the country. So you see, the warming in the extremes is more significant, more severe than the warming in the mean. And that's with all the implications for our health, for food productivity and water availability and so on. And also other things like electricity generation. When it comes to rainfall, that's far more variable. So what we're finding is certain parts of the country are seeing pretty significant changes, although you don't see a signal when you average over the entire country. So the Indo-Gangetic plains in particular have seen a declining trend in rainfall over the last 6, 7 decades. The Northeast, even more significant, up to, if you want me to give numbers, up to 1 millimeter per day per decade, which is quite a lot. Um, uh, even given the fact that the baseline rainfall in the Northeast is very high. And so these are changes happening. Parts of the Western Ghats are also seeing declining rainfall, quite significantly declining rainfall, right? But when it comes to extremes, it's generally the central parts of the country and western parts that have seen the largest increase in extreme rainfall events. So parts of Rajasthan, parts of Gujarat, these are among the regions where we are seeing a strong signal of increasing rainfall extremes. Yeah. So rainfall is generally very, very variable. That, of course, we know. Uh, uh, we see that in the data, and the same thing is happening with projections. So one of our big concerns now is that models are having a difficult time with projecting rainfall, and therefore rainfall projections is a widespread across models. That's what we need to really constrain the future work. To some degree, generations of models have seen improvements in our ability to represent the Indian monsoon, but there is work to be done, especially to get fine-scale projections, rainfall projections for the future.
Right. If you could elaborate a little bit more on the actual implications on the ground, especially in the extremes that you spoke about, that would be a little useful. Yeah.
Well, the sort of the obvious stuff is, of course, heat waves and droughts with changing temperature and rainfall patterns. But let me point to something which there is less work on, which is the emergence of compound extremes. So you can have a heat wave and you can have droughts or floods, depending on whether you have excess rainfall or deficit rainfall. But the impacts are compounded when you have concurrent extremes across large parts of the country, say a heat wave which occupies a third of the country, you see, or a heat wave and a drought that occur sort of in succession. So you have a summer heat wave followed by a drought. You see, so the heat wave, what that does is it dries out the soils, but that doesn't get replenished if there is a deficit rainfall season concurrent or subsequent to the summer heat waves. And therefore, these compounded extremes and the impacts coming from them are becoming the matter of bigger and bigger concern. So that's something we wrote about in a recent paper. Uh, Much less work has been performed on trends and projections of compound extremes than the projection of individual extremes. So that's where we need serious scientific research focus now on how compound extremes have changed. And by the way, heat wave drought is not the only thing. Coastal regions in the country might see sea level rise compounded by extreme cyclones, cyclonic storms, which cause storm surge. And so the storm surges can be bigger because the baseline sea levels have increased because of not just climate change, but also other reasons.
Right. So, with the problems kind of laid out, the obvious next question is what are the solutions? And one of the things that you have cautioned against is focusing purely on carbon reduction strategies, as these could have kind of ecological and social implications. If you could take us through why, a unidimensional approach might not really be good.
Right. I will reiterate one example just briefly, which is the food productivity loss, right? So it could happen because of climate change reasons, directly affecting the crops, but it also is happening because of pollinator loss and soil biodiversity loss. So you see, if we frame the problem as just one of climate change, our solutions may not cover the other changes we are causing, which is also leading to food productivity loss. Uh, let's take sort of the example of the electric vehicle, which now are seen as one of the major solutions to the problem. Now, what problem? Is it the climate problem? Is it the anthropogenic problem, which is a much larger issue? So let's break that down. Let's imagine that we replace the entire fleet of fossil fuel private vehicles on the road, all the cars, with electric cars. Now, in principle, at least, we would see a reduction in air pollution, at least in the cities where most of them fly, and in carbon pollution from transport, right? Now, leaving aside whether let's imagine that it is, in fact, these electric vehicles are being fueled by solar and wind, okay, not electricity generated by by the thermal power plants, in which case there's no difference anyway. But let's imagine they're powered by solar and wind. Even then, you still require roads for them to fly on. So you still require bridges. You still require a great deal of infrastructure. As you build more of this infrastructure, now where do you build this infrastructure? Well, wherever you build, there are either people living or nature living. So either you're going to disrupt human systems or ecological systems, the more of this infrastructure we build. So you can solve some problems potentially, but at the cost of perhaps causing others. And we are trying to solve one global problem, but in the process, we might be affecting local communities and local ecology, and therefore creating a bunch of local problems. The problem is even bigger than that. Electric vehicles necessarily require batteries. Batteries require critical minerals, rare earths, and so on. And most of these critical minerals and rare earths, they're all coming from holes in the ground, mining, most of them in the global south, in developing countries. Lithium will come from the lithium triangle in South America. Cobalt will come from parts of Africa. Nickel, copper will come from other parts, and so on. Mining is a highly invasive process. It creates tremendous local pollution. Air pollution because of fine dust, water pollution because these are heavy metals, which inevitably, invariably leach into the water, and which itself can cause crop loss and water pollution, undrinkable water basically in those. So once again, in the process of trying to solve a global problem, we are in fact already ending up creating local problems in multiple parts of the world, most of them the developing countries. Which brings us to the issue of justice. When we say green vehicles, which is sometimes how they are labeled, what does that mean? Green for whom? It's green for the people that can afford to buy these vehicles and drive them. But it's certainly not green for the people where the mining is occurring, increased mining for minerals which were not earlier used. They're being specifically used for the electric transition. And therefore, there are new communities, specifically poor communities who can never afford these vehicles in the first place. For them, it's certainly not green. So, green for whom becomes the question of justice, right? So, unless we take the climate system, the ecological system, human systems, and the larger issue of justice, we can never really come to a solution which actually tries to address all of them.
It's a very interesting point, especially when India is kind of There's a lot of focus in India on solar and wind and other forms of renewable energy, which obviously has its benefits. But like you point out, there are kind of payoffs. What, in your opinion, can say the government, policymakers, and even private companies do, especially private companies in the sector, do to kind of strike this balance where you're not harming the community or local resources, but you're still providing some kind of energy alternative?
Mhm. Yeah, I think one way to look at it is what are the imperatives from different parts of our system. So you have the economic imperative, you have the justice imperative, you have the climate imperative. The climate imperative is to reduce carbon emissions because the problem is carbon. The economic imperative is to do it as least cost. Right? There might be a governance imperative. What are your governance structures, and so on. There might be an ecological imperative if we even care about that, which very often, unfortunately, doesn't get the same attention. Um, let's take an example yet again. This was called. Let me get this right. I think it's called the Western Green Energy Hub. It's being set up in Australia. It's a massive parcel of land in Australia where they're planning to set up solar and wind up to 50 gigawatts, solar and wind. But the manner in which they're setting up is very interesting. It's one of the few for such a large scale project, massive. I mean, there's nothing of that scale so far in the world. Firstly, most of the land that it occupies, actually, the Aboriginal they have land rights over them to various degrees. Not necessarily that they own the land, but they own the right to work on the land, that kind of thing. So depending on the part of the country, they have different rights there. Now, there are different models. For example, if I'm not mistaken, Pavagada in Karnataka, it has leased the land from the farmers that own the land where now that massive solar farm exists. So they've leased the land. I think that's Pavagada. What they've done in Australia in this particular project is different. They've actually given ownership and governance rights to the people whose lands it will be sited on. And so they stand to benefit from the profits that will emerge and the energy that will emerge from these this project. See, so I think it's probably the only project of its kind, of its scale, where this has been attempted. And this now is something which takes the actual social into account and not just the energy, a clean energy production, right? So perhaps these are the kind of ideas we require moving forward. And by no means am I saying that that project is perfect, not at all. There will be several problems in implementation and so on, but that's probably the line we need to take so that we are assured that the local communities have a say in what is being done with their land. They are adequately compensated for their loss of livelihood because the project is replacing the activities they would have been doing, whether it's farming, whether it's hunting, and so on. And they have a stake in the whole issue and a say in the matter, including governance. So I think these are the directions we need to push forward in. Of course, now whether that would be in line with various interests, there are governmental interests, there are corporate interests, and so on. That's probably the larger question. Which of these stakeholders are willing to compromise on their particular interests so that it serves the greater common good?
Right, which was actually my next question. And this is often asked of people who advocate for a more climate friendly kind of approach. Is that, but India is a developing country and we have rising aspirations and we're a growing country. So obviously there will be development needs and infrastructure needs. Can a balance be struck? And can we actually prioritize the planet and local communities and justice when the focus for us is to grow economically?
My comments on this will be a little more abstract. Uh, mainly because on the issue of development, my work has gone into that direction only the last 2 years. So my thoughts are evolving as I work on it. First of our papers only appeared 6 months ago, although we are working very actively on it now. So I could make larger comments. One is, I think, the one critical question as Donella Meadows, one of the great systems thinkers, pioneers, she said, well, we need to ask fundamental questions like development for whom, what purpose does it serve, who benefits, and who pays the price. Now, if we do not ask these questions and take development as this sanitized good, we miss the larger picture and the system's problem. right? So, for example, if we have a high-speed rail network created between two cities, right? Now, it serves a certain purpose, but if we have a low-speed rail network, which is much more affordable, passing along the same route, see, because you need to acquire land, which is otherwise used for different purposes, all along the route, right? So we need to ask which of these solutions serves what purpose, who gets to use these forms of transport, and what are the benefits, not just from a climate sense, but from a social and ecological sense. But we need to ask that because without that, our solutions will never address multiple problems at the same time, right? So I think asking these fundamental questions, larger questions about development, why, what purpose, who does it serve, who does it not, are sort of that's why I said I was going to answer in the abstract.
Which is also another very interesting aspect of your work is kind of focusing on local knowledge and grassroots kind of initiatives uh, for planet positive approaches. Can you shed some light on what these initiatives are? Any interesting stuff that you've come across in your work?
Okay. Um, I think I would go back to that example from Chad once again, where they use their local knowledge of the migratory routes in order to map out where the conflicts are happening currently and where they could potentially happen in the future. So you use that local knowledge of how people are operating, how they're conducting their lives and livelihoods, use it together with scientific knowledge of what we know about where changes are expected to happen, and successfully, or at least try to marry the two together. All right. And that's where local knowledge and sort of the scientific knowledge can come together to create a better model for risk and therefore risk mitigation. Another example could be from Nepal, where they have an early warning, a flood early warning system, where they've created interesting systems where upstream communities can warn downstream communities about flood risk. So when they see waters rising, um, they've created chains of communication between local communities so that they can transmit that information downstream and risk mitigation can at least be done downstream. Of course, this is together with the regular sort of governmental systems and so on, but to complement that, not supplement it, complement it. So this is how you can use local knowledge and local help complemented together with sort of the larger governance systems and create a more effective system of information delivery.
Right. I think one of the most interesting threads of this conversation was how you pointed out the unintended consequences of what we think are actions that are good for the planet. But that's a very kind of nuanced thought. How can listeners, policymakers, even climate investors, people not actively studying this, can be more aware of these trade-offs and be aware of these unintended consequences?
Let me break that into two questions with your permission. One is, I think I'll take one more example of these kind of relationships and then come to the actual question you're asking about how do we make people aware of them, right? Because this is a particularly beautiful example. Some years ago, economists from the IMF, International Monetary Fund, they proposed whale carbon offsets. What they mean by that is this. Whales have a remarkable role in stabilizing the climate, or at least when whales were their historic populations. The way they do that is whale feces are rich in nitrogen and iron, which are nutrients which are otherwise lacking in the ocean waters. So, in when you have healthy whale populations, you have a lot of this nitrogen and iron fertilization of the ocean waters, which gives rise to phytoplankton, which are photosynthetic microscopic algae. Phytoplankton take in carbon dioxide from the atmosphere, and they are also considered responsible for about 50% of the oxygen in the Earth's atmosphere. So, carbon sequestration as well as oxygen production, because the whales are helping to fertilize the ocean waters. In addition to that, when the whales die, They are enormous, several, at least tens of tons, and in the cases of larger whales, 100 tons. They sink to the ocean floor, and that gets so the carbon in their bodies gets trapped there. So whales are highly efficient at carbon sequestration, right? So what these economists did is they said this is the sequestration service which can be priced, and they put a price of $3 million on the whale sequestration service. Now, to my mind, deeply problematic. Because what they're saying is, so what they were proposing is we make whale carbon credits, which people can buy, and you can use that money in order to conserve whales. So it's a manner of whale protection in the name of climate conservation. The problem is this. A female whale, by this logic, is more efficient than a male because they give birth to calves, and the calves grow up, becomes whales, and so the cycle continues. Males do not directly do that, and therefore a female is more valuable than a male, which is more valuable than a juvenile. An adult is more valuable than a juvenile. And in this logic, the phytoplankton and the krill have no role whatsoever. They have no value because they're too small. But in the absence of phytoplankton and krill, the whales could not exist. So you see, this carbon reductionist approach, where we essentially reduce the value of the whale to the carbon it carries, it completely ignores the larger ecological context in which the whale exists. It's those relationships, the intricate, complex ecological relationships, which gives this entire system its stability and its resilience. If those relationships are eroded, it loses its resilience, right? So the relationships are actually what we should be valuing, not the specific creature itself in some very myopic way. Now, these are intricate relationships which even scientists have taken a while to explore and to pin down, right? Now, how do we make that more sort of visible to the larger community of us? Well, I guess stories and media are two obvious things that come to mind. I know some people who are writing stories around these, which are aimed not just at children, but at adults. So I think the arts have a great deal of, they have a very big role in communicating these ideas in a manner that science cannot do. Yeah. Secondly, the media. How does the media cover these issues? Now, of course, we've written in the past and we've written it sort of in the media, and therefore they've carried these stories and these scientific articles. But one of the problems I fear is much of the media has been corporatized. Many of these same corporates that own the global media now, and it's being consolidated, are also the ones with mining interests or infrastructural interests, right? Now, can the same media, corporate media, really do both, where on the one hand, they don't compromise the other interests of these corporates, but at the same time, they carry these kind of articles and stories, which are important for all of us to understand. So the problem is larger than just merely communication. It's this larger sense of who owns the means of communication. And that is something which I have no answers to that whatsoever, and I'm not well placed to be able to answer that question. It's a question for all of us to try and understand. Firstly, recognize and then try to find solutions for together. So I'm pointing out the problem and not solution, I'm afraid.
Right. So finally, to kind of end on a hopeful note, amidst all of these challenges in your fieldwork and in your studies and research, what is that one initiative or idea that you've come across that gives you hope for the future of India in this warming kind of climate, but also the future of the planet?
I'll talk more from a planetary perspective, global perspective, rather than just an India perspective. Simply because that's kind of the nature of my work. I take a global and systems perspective. Specific examples: Enrique Peñalosa's public transport revolution in Bogota, in Colombia, is, to my mind, one of the inspiring examples. In the 4 year term as mayor in Bogota, and Bogota is one of those cities, global south cities, which has much the same problems as many Indian cities, so it's particularly relevant to us. What Enrique Peñalosa did as mayor, he transformed the public transport infrastructure, created hundreds of kilometers of biking meaning bicycling tracks, covered, protected, from the elements from other traffic. He reduced, he dramatically increased the amount of bus infrastructure and reduced the size of the roads for private transport. So it was both a carrot and a stick. The carrot being much better public transport infrastructure, smooth flowing because he created dedicated lanes for buses, and then reduced the amount of space and therefore the traffic jams for people using private transport. And and therefore, this of course would reduce carbon pollution, air pollution, and so on. But the really interesting thing is this happened in the early 2000s. He did not do this in the name of climate action. He did it in the name of democracy. His interpretation of democracy was a radical democracy where it's not just about a vote, it's about our access to common resources. So even if you don't have money to buy a massive car or an SUV, you still have the same rights to common public infrastructure. And therefore, a bus which carries 100 people rather than a car which occupies the same space and carries only 4 people, it's a no-brainer. The bus has right of way because that gives more people access to the public commons, right? So he did it in the name of radical decentralized democracy, but the same, you could do the exact same thing in the name of climate action or ecological action. So these are solutions which have successfully combined multiple perspectives at the same time, have a justice element to it, not just a climate and carbon element to it. Another South American country, I don't know why, uh, since Lula has come to power, the deforestation rates in Brazil have dropped dramatically compared to the previous regime, which could not care about many of these niceties. Um, and this has been verified through satellite data that deforestation rates have dropped dramatically, 30 to 40% in the first year since Lula came to power, right? Now, that does multiple things. Of course, avoided deforestation has all the climate benefits and natural benefits, ecological benefits, but it also protects indigenous peoples' land rights. People that live there on that land, indigenous, have been protecting that land, in fact, and the forest for a very long time. Um, and so, again, it manages to accomplish multiple things at the same time. So these are the kind of initiatives that I see needs careful ad adaptation, not adoption, but adaptation to Indian conditions and other conditions um, that could go some way towards trying to take a systems view and therefore a systems view to the solutions.
So we'll start with the rapid five. First question. What is that one climate threat that you wish policymakers or climate investors understood better?
Compound extreme events. So far, we've been looking at extreme events and their impacts individually. Compound events are where they're happening concurrently, simultaneously, one after the other, and that's what we need to pay attention to.
A recent finding of a scientific finding on India's climate that gives you hope.
Our understanding of the aerosol impacts on climate change is becoming better with time. And very, very recent work, we found that reductions in air pollution in other parts of the world may actually benefit India's monsoon. And that's where I hope more research will focus and we'll find better answers.
Right. One policy change that could help India align its development goals with planetary boundaries.
Very hard. Let's skip this question.
Sure. One kind of grassroots initiative or action that really gave you hope and kept you inspired to stay in this field.
I don't know if I would consider what happened in Bogota as a grassroots action, but it is certainly much more grassroots than the public transport infrastructure in Bogota, Colombia, uh, that was decentralized. And that, I think, was one of the more inspiring actions, which combine many different perspectives, not just the climate one, but justice and so on. That's where I see much more action happening.
Right. And final question, why do you keep pursuing solutions to these climate challenges?
One is my personal inclination, which is I've always been quite interested in issues of justice, and not even just climate justice, even social justice. And the other one is intellectual. The more complex the problem is, the more it pushes you to delve into other fields, and that certainly happened for me. So both the personal and the intellectual.
Thank you so much for this conversation and for kind of really challenging the way we look at our climate solutions. Thank you for your time, Chirag.
Thank you so much, Vishuna. It was a pleasure speaking with you. Thank you.